Hey guys, so today we're going to look at lesson 3.1. So this is starting out unit 2. So each unit has about 2 modules in the book. So that's why we're in module 3 and we're starting unit 2. So unit 2 will have modules 3 and 4 in it. Alright, so today we're going to look at linear equations in standard form. Alright, so if you remember, a linear equation is an equation where it has x to the first power. So there are different ways to see a linear equation. Last year in 8th grade, or Math 8, you should have seen y equals mx plus b. Okay, because this is called slope-intercept form. And today we're going to look at standard form. Standard form is ax plus by equals c, where a, b, and c are just numbers, but your two variables x and y are on the same side, where for slope-intercept, y is by itself. And then there's another equation that you will see as we go called point-slope form, which is y minus y1 equals m times x minus x subscript 1. So there are 3 basic equations that you will see, all with linear equations. So linear equations can be seen with many different representations. Alright, so let's see what we're going to learn today. Alright, modeling real-world linear relationships involve defining your variables, deciding the number system in which your variables exist, and thinking about the mathematical relationship between the variables. Once you have the equation, the graph can help you find solutions that satisfy the situation. Alright, so example we're going to look at, Joel has $192 to spend on frames to display his art at the local art show. The large frames cost $8 and the small frames cost $6. Alright, so that's information that we need to remember. Okay, so $192 to spend, large frames are $8, small frames are $6. Alright, it says write the equation. Alright, so we're going to complete the solution to provide the missing information. So x, we're going to let x represent the number of small frames. Okay, small frames are $6 each. So y will represent the large frames. The amount in dollars that Joel spends on small frames is $6. So 6 times x, since we let x represent the small frames. And the amount in dollars that Joel spends on large frames, again, large was your y, and large frames cost $8. So we're going to have 8y. And the total amount he can spend on large and small frames together is 6x plus 8y. Alright, to write a linear equation that models this situation, because Joel spends a total of $192, the linear equation that models this situation is 6x plus 8y equals $192. And again, that's just the information that we were given above. Alright, it says find the intercepts from the graph. Complete the solution by providing the missing information. Alright, so if we look at this graph, we can see that this is our x. Let's change this to a lighter color. We can see that it crosses the x-axis here. We can see that this is our y value, and it crosses the y here. So let's see what this information will tell us. Alright, it says the x-intercept is x equals, okay, so you can see that this is 30, 35, 40. It's between 30 and 35. So it's going to be about 32. This is the point at which it crosses the x-axis, okay? Again, this is the x-axis right here. The y-intercept is, we can see this is 20, this is 25. It's not quite to 25, so that means it's going to be 24. And this is the point where the graph crosses the y-axis. All right, Interpret the intercepts. So complete the solution by providing the missing information. All right, the x-intercept means that Joel can purchase. All right, again, the x-intercept was the one on the bottom. The x-intercept was about 32. So it means that he can purchase 32 small frames, because the small frames were your x, and he can purchase about 0 large frames at the same time. So you can see, like if you're looking at the graph, this is an ordered pair, and this ordered pair would be 32, 0. That would be your ordered pair for that. And then if you look at your ordered pair for the y, okay, this would be 0 would be your x, and y would be 24. All right, so that's just coming from looking at the information on the graph there. All right, the y-intercept means that Joel can purchase 24 of the large frames if he purchases 0 small frames. All right, the point 24,6 is a solution because if you plug in x and y, this would be your x and your y. If you plug that into your equation, 6 small frames, or $6 for each small frame, and $8 for each large frame. If you check this equation, it will be $192, which is what he has. And because 24 and 6 are whole numbers. Okay, so these are whole numbers. You can't have a fraction of a frame. We're talking about a real life situation, so that's why they're talking about whole numbers here. The point 10, 16.5 is not a solution because 16.5 is not a whole number. So that means you can't have 16.5 large frames. All right, find other solutions. Use the graph to find other solutions. So your solutions are the points along this line that are whole numbers. Again, we can't have half of a frame if he's going to be showing something in the art gallery. So we have to figure out what whole number values will work. All right, so 8 and 18. So $6 for 8 frames. And $8 for the large 18 frames. I might have said that backwards, but 6x plus 8y is our equation, so all we have to do is plug in the 8 and the 18 for our x and our y. If that equals 192, that means that is a solution. He could buy that many frames, small frames and large frames, in order to put his work for the art gallery. 16 and 12, again, my equation is 6, and we've got 16 as our x, so we need the 16 to go first and the 12 to go second because those are whole numbers. Those will also work. All right, so looking at linear equations in standard form and reviewing their x and y intercepts. If you have any questions, please let me know.